Hello students, the topic is breadth first search and depth first search traversals. I will be explaining these both graph traversals in this lecture today. So, first of all, in order to understand the breadth first search and depth first search, we must be familiar with two things. These are, number one is visiting a vertex and exploring of a vertex. So what does it means by visiting a vertex? Like approaching a vertex, that we have visited the vertex 1. This is a visiting a vertex. Exploring of a vertex. Exploring of a vertex means that once we have visited the vertex 1, then we have to explore all the adjacent vertices to the visited vertex. This means exploring of a vertex. So in order to understand these both terms, the breadth first search and depth first search, you must be familiar with these two things, visiting of a vertex and exploring of a vertex. So let us start the explanation of the topics breadth first search and depth first search by a very common graph. Actually it is a tree, but tree is also a graph. So you can start from any vertex, right? But here I am starting from the vertex number 1. See, if I have started from the vertex 1, then the adjacent vertices are 2, 4, 5. I have written in them here 1, and the adjacent vertices are 2, 4, 5. You can write them in any order unless and until it is not given in the question that you have to follow the increasing order, or in when you are given alphabets in place of the 1 2 3, you are asked to follow the alphabetical order. So here there is nothing given in the question, so you can write in any order. So the adjacent vertices of the vertex 1 were, we visited the vertex 1 and then we explored the adjacent vertices. These vertices are 2, 4, 5. Then we will cross this one, start exploring 2. What is attached, what are the adjacent vertices of 2? These are 7, 3 and 6, right? So these are the adjacent vertices of 2. Start exploring 4. There is nothing adjacent to 4. Start exploring 5. There is nothing adjacent to 5. We have already explored the 1, right? Start exploring 7. So to adjacent vertex to 7 is 2. We have already explored the 2. Start exploring 3. So the adjacent vertex to 3 is 2. So we have already explored it. And the last vertex is 6. The adjacent vertex to 6 is 2. So we have already explored that 2. So there is no need to explore it again. So this is how you can apply the breadth first search, right? So breadth first search follows the FIFO, first in first out. So once you have visited a vertex, you have to explore it completely and then visit the next vertex, right? So this was all about the breadth first search. Now we will understand the depth first search. Here, like in the same is the approach in the depth first search, that you can start from any vertex unless and until you are asked or given any condition in the question. So I am starting from the vertex 1. So what are the adjacent vertices to 1? That is 2. So now the other vertices are 4 and 5, but I am not going to visit them. I am not going to explore the vertex 1 completely. Once I have visited the next vertex, I have to suspend this vertex, the previous one, and start exploring the next one. So start exploring 2. The next adjacent vertex to 2 is 3. Suspend 2, start exploring 3. Now, once you have visited the vertex 3, you have approached the vertex 3, suspend 2 and start exploring 3. Adjacent to vertex 3 is 2. Start exploring vertex 2. adjacent vertices are 6 and 7, right? Start exploring 6. There is adjacent vertex is 2, it is already explored. Then 7, start exploring 7, adjacent vertex is 2, it is already explored completely. Then it will come back to the first vertex, right? It will move back to the first one. Explore 1. The adjacent vertices here are 4 and 5. So we will write here 4 and 5. So this is how depth first search is different from the breadth first search. So in depth first search, once you have visited the next vertex, no need to explore the previous one completely. First explore the next one completely, and then we can go back to the first one at the end after exploring all the other adjacent vertices. Now we will discuss the breadth first search and depth first search in detail using this tree or graph. So you can see that here we are having 10 vertices, and first we will understand the breadth first search. So in order to apply the breadth first search, I will use one data structure, that is Q, right? So I will use the data structure, that is Q. I will draw the Q here like this, as you can see, right? And then I will there you can start, as I have already said, that you can start from any of the vertex. So here you can start from the any of the vertex, right? So here I have started from the vertex number 1. I will write the 1 in the queue in case of the breadth first search. Start exploring the 1, right? After placing it in the queue, I will start exploring the vertex 1. So what are the adjacent vertices to 1? They are 4. So I will write 4 in the queue. Then the next is, right, I will also draw it like here in order to generate the spanning tree for the breadth first search. Afterwards, I will place 2 in the queue, as the second adjacent vertex to the 1 is 2, right? So 1 is now fully explored, you can see. I will cross it from the queue as it is fully explored. Then I will start exploring the next vertex, right, that is 4. So what is adjacent to 4? That is 1 is already explored, and the next vertex is 2. So I will write that is 3. I will write 3 in the queue and in the breadth first search as 3. So now 4 is fully explored. I will cross it. Now I will start exploring the next vertex in the queue, that is 2, right? So what is adjacent to 2? That is 5. I will write 5 here. Next is 8. I will write 8 and in the breadth first search, and adjacent vertex is 7. I will write 7 here. So now 2 is fully explored. I will cross 2 from the queue, and then I will start exploring the third vertex, vertex 3. So what is adjacent to vertex 3? That is 10 and 9. So I will write 10 first and then 9 first in the queue and also in the breadth first search, right? So now again I will cross 3 and I will start exploring 5. So what is adjacent to 5? That is 6. I will write it here in the queue and in the breadth first search, right? So we are done with all the vertices, but we will check for the remaining vertices also, right? So what is adjacent to 8? That is 7 and 2. So they are already explored, and 5 also. 5 is also already explored completely. We'll cross it. So now 7 adjacent vertices are 8, 5 and 2. They are already explored. Cross it. Then 10, What is adjacent to 10? That is 3, that is already explored. Cross it, move to 9. 9 adjacent vertex is 3, that is already explored, so no need to explore it again. We will cross it and move to the next vertex, that is 6. So what is adjacent to 6? That is 5. So 5 is already explored, so no need to explore it again. So now we have also drawn the spanning tree using the breadth first search, as we have checked that we have started from the first vertex, that was 1. Then we check that what are the adjacent vertices. So the adjacent vertices to 1 were 4 and 2. Then 1 was fully explored. Then we explored 4. What was the adjacent vertex to 4? That was 3 and 1. So 1 was explored fully already. So we place 3 here. Then we explored the 2. So what were the adjacent vertices to 2? That were 5, 8 and 7, right? And then we came back to the 3 and we explored it. The adjacent vertices were 10 and 9. Then we explored 5, so the adjacent vertices were 6. So this is how we generated the breadth first search spanning tree, or the BFS spanning tree, for all this breadth first search data we have uh, got from this graph or tree. So this was all about the breadth first search. Now we will understand the depth first search using the same example. So in case of the depth first search, I will use one data structure, that is stack, right? So how I will use the stack over here, I will explain it to you while finding out the depth first search. Here in the depth first search, the approach is same like the breadth first search, that I can start from any vertex, and here I will start from the vertex number 1. So what are the adjacent vertices to 1? That are 4 and 2. So I will first go for 4. So I have written here 1 and 4, right? So now I have approached the next vertex, second vertex, that is 4, the adjacent vertex of the vertex number 1 from where I have started, right? So I will suspend the previous one and start exploring 4. How I can do that? I will place 1 here and I will suspend that and I will start exploring 4, right? So I have placed the 1 and 4 in the stack and start exploring it, right? Then the adjacent vertex to 4 is 3, right? So I will suspend 4 and start exploring 3. I have placed the 3 in the stack. And so what is the purpose of placing all the vertices in the stack? Is that we can place all the vertices in the stack so that we can explore them later. We will come back to all the vertices and we will explore them. So as now we are exploring the vertex 3, right? So we will explore the vertex 3, right? So what is the adjacent vertex to 3? That is 10. We will suspend the vertex 3 and start exploring 10. There is nothing adjacent to 10. So we will come back to the vertex number 3 and we will explore it again. So if when we come back to the 3, you can see that the adjacent vertex next to 3 is 9. So we will write it here in the DFS. Right now we will explore 9. There is no other adjacent vertex to 9, so we will come back to the vertex number 3. So now vertex number 3 is completely uh, uh, explored from here, from the bottom, but at the top we are having 4 and 2. So 4 is already visited, so the next vertex will be 2. So we'll write 2 here in the DFS. So what are the next vertices to 2? We will suspend the vertex number 3 and place 2 in the stack and start exploring it. So the next adjacent vertices to 2 are, that is 8, right? So we will write 8 in the DFS and suspend 2. We will also write 8 in the stack and start exploring it. So next adjacent vertex is 7 to the 8. So we will suspend 8 write 7 here and also place it in the stack and start exploring it. So what is the next adjacent vertex to the 7? That is 5. We will write it in the DFS and we will also place it in the stack and start exploring it. So what is the next adjacent vertex to 5, while as we are exploring 5 now? So the next adjacent vertex is 6, so we'll write 6 here and in the DFS, and we will also place it in the stack and start exploring it and suspend 5. So as we are exploring 6 now, so there is no other adjacent vertex to 6, so other than 5, so it will come back to 5. Here it will move back to the stack. Here you can see it will explore 5. What are the adjacent vertices? That is 2. 2 is already visited or explored. 7. 7 is already visited or explored. 6 is already visited or explored. 8 is already visited or explored. So, we conclude that 5 is completely explored. Remove it from the stack. The next one is 7. Start exploring 7. The adjacent vertices are 5. 5 is completely explored. 8, it is already visited and explored. 2, it is already explored and visited. So it means that 7 is completely explored. Remove it from the stack. Next is 8. The adjacent vertices are 2, it is already visited and explored. 7, it is already visited and explored. 5, it is already visited and explored. So 8 is also completely explored. Remove it from the stack. The next is 2. So what are the adjacent vertices to 2? That is 1. So 1 is already visited and explored. 2 is already 3 is already visited and explored. Next is 5, 7, 8. So all these vertices are already visited and explored. So 2 is completely explored. Remove it from the stack. Next is 3. So adjacent vertices are 4, 2, 10 and 9. So all of these are already explored and visited. So 3 is completely explored. Remove it from the stack. The next is 4. So 4 adjacent vertices are 3, 2, 1. All these vertices are already explored and visited. So also remove it from the stack. So 4 is completely explored. The last one is our first vertex, the starting vertex 1. So adjacent vertices are 4 and 2. So we have already visited and explored these vertices, the 4 and 2. So this is how we have applied the DFS on this graph or tree using the data structure stack. Here we have also drawn the DFS or depth first search spanning tree from this DFS. Like see, we first started from the 1, started its exploration to 4, 1 was attached, adjacent vertex was 4, to 4 the adjacent vertex was 3, then with 3 the adjacent vertices were 10, 9 and 2, and then to 2 the adjacent vertex was 8, and then to 8 the adjacent vertex was 7, and then to 7 the adjacent vertex was 6, and then to 6 the adjacent vertex was 5. So this is how we have drawn the DFS spanning tree from this DFS, right? So in this lecture we discuss the breadth first search and depth first search graph traversals. The difference between both is breadth first search follows the queue data structure and depth first search follows the stack data structure. Breadth first search follows the FIFO system, first in, first out. So it means that once you have visited the vertex, you have to explore it completely and then move to the next one. First in, first out. So that vertex that has come first, it will go first, right? Depth first search follow the LIFO system, which means last in first out. So we have explored the first, you have to explore the first one at the last, right? So here as you can see we were having two vertices adjacent to 1, 4 and 2. First we visited the 4, then we started exploration of the 4. But we were having another vertex here, that was 2. We did not visited it, or it started its exploration. This is how it follows the LIFO system. So this was all about the breadth first search and depth first search.